Hey all, in this video, we are going to learn chain rule, prime time and work concept. Chain rule is very important to solve some of efficiency based questions as well. And those efficiency model we'll see in the next video. So in today's video, we'll see chain rule only. So let's start. First of all, let me explain what is the concept of chain rule. So guys, when you see in our day-to-day life observation, if you want to complete more work, more number of people are required. I can say more men are required. So we can say work is directly proportional to men. So to finish more amount of work, more number of people are required. To finish less amount of work, less number of people can be required. So we can say work is directly proportional to men. And similarly, to finish more amount of work, more number of days are required, right? So more amount of work will take more number of days to finish the work. And similarly, more work can be done by working more number of hours per day. If you work for more time, you can able to finish more amount of work, right? So work is directly proportional to the number of hours as well, number of hours per day, friends. And work is also proportional to efficiency. More work can be done with more efficiency, less work can be done with less efficiency. So if we combine all these four aspects, then we can say that work is proportional to men into days into hours per day into efficiency. So we can say work is proportional to men into days into hours into efficiency. So this is called chain rule. When we multiply men with days, hours, and efficiency, we will get the total amount of work units, friends. We will get work units. So we'll call it as work units. Sometimes in a problem, efficiency and hours may not be mentioned, which means they are constant. That time you can say, so if in a specific question, if we talk about work, men, and days only, then I can say work is proportional to men into days. So what is the assumption there? We can assume that hours and efficiencies are same for both people, nothing to worry. And if anybody is from math background, by removing this proportionality constant, we can say work 1 by work 2 equal to M1 D1 H1 E1 by M2 D2 H2 E2. So we can say this is a simple relation for chain rule. So nothing to worry about all these relations. Keep in mind, if you multiply men with the days, hours, and efficiency, you'll get the total work. So with this small concept, we will try to solve 9 to 10 questions in this video, right? Let's start the first question. If 4 people can do a piece of work in 16 days, working 5 hours each day, in how many days the work will be completed by how many people? By 20 people working 4 hours each day. So friends, if you have any confusion, let us mention initially 4 men are there. So we can say M is 4. Number of days are 16 days. And they work for 5 hours each day, right? Number of hours are 5 hours. As there is no point about efficiency, we can say efficiency is constant. Now, how do you get work? Work is equal to product of all men, days, and hours, right? So work units equal to 4 into 16 into 5. Now, the same work is completed with some other set of conditions. What is that condition? 20 people can work. So in the second case, I can say men too. The second case, men are 20 people, and the day work, number of days we don't know, but number of hours their work is 4 hours, right? H2 is 4 hours. Now the work is same. They mentioned the same work, right? In all cases, we'll try to take work is same. So now here this work is same as this work, right? So now the first work is equal to second work. What is work in second case? Men into days into 4 hours. So 4 cancel. 5 goes 4 times in 20, and 4 goes 4 times in 16. So in second case, the number of days are 4 days. So simply by using men units, can simply work out. As it is a first question, we use the basic standard expression. So in case if you try to solve an exam, keep it in mind the relation. Then directly you can say 4 people, 16 days, 5 hours work is same as 20 people, D days, 4 hours. And a single step, you can finish that. Right? Is it clear, guys? So in that way, you can easily work out the question. Now go for second model. Second question. If 20 people can complete 2/5 of the work in 6 days, working 4 hours each day. So there is some work, 2/5 work, and that work is how much, friends? That work is men, 20 men, 6 days for 4 hours day. Now this work is done by some other set of conditions. Then how much work will be completed by 30 people, 2 days, each day 8 hours? Let us try to see what are the men units, work units in both cases. 26 are 120, 124 are 480 men units here. Here 32 are 60, 68 are 480 units. So unfortunately, with the different set of numbers, they are doing the same work, 480 units, 480 units. Here 480 units represents 2/5 work. In fact, this also should represent same, right? So they did simply 2/5 of the work. So option D. So simply remember, work is equal to men into days into hours. Next question. Now we change some numbers here. 10 people complete 2/5 of the work in 8 days, working 5 hours each day. How many additional men are needed to complete the total work in 14 days? Remember this, total work in 14 days, working same number of hours each day as earlier. So let us make a simple diagram for this to understand a better perspective. So guys, initially 2/5 of the work is done. Means what is the balance work? Balance work is 3/5 of the work. Out of 5 units, 2 units is done, right? So 350 is the work left. So this is work 1 and this is work 2. And in the first case, they work 10 people, right? So number of men in the first case is 10 people and they work for 8 days, 5 hours. So days 1 is 8 days and H1 hours is 5 hours. How many additional men? We don't know how many men are actually working in the second case. Let us take M2 as M2 only. And they work same number of hours. So H2 is also 5 hours. And the total work is to be done in 14 days. But out of 14 days, initially they work for 8 days. So the remaining days are 6 days only. I mean, the balance work, 3/5 of the work has to finish in the balance 6 days. Now we have a relation. In the beginning step, we discussed one relation. W1 by W2 equal to M1 D1 by M2 D2. So guys, why I'm not considering hours? Because hours is constant, right? When the variables are constant for both cases, nothing to worry about that specific variable. Now first work is 2/5 work and second work is 3/5 work. This is same as 10 men work for 8 days in the first case, and later on we do the number of men, but they work for 6 days, right? So here 5 cancel, 3 goes 2 times, guys, 2 goes 4 times, 2 goes 2 times and 4. So 10 into 2, 20. So men 2 is 20. So friends, to finish the balance work, balance 3/5 work and 6 days, they need 20 men. But out of the 20 men, initially 10 people are already existed. So how many extra are joined? So out of 20 people is already joined, no? Yes or no? So how many more should join? So if 10 more people join, they can finish the work in the stipulated time. So the answer is 10 days. So as you are in the beginning of your learning process, I am giving this W1 by W2 relation. Later on, when you solve another 5-6 questions, no need to worry about all this. You can do by own, right? Without using this formulaic approach, you can think of that. That obviously that will come, right? Nothing to worry. Next question. Let's see here. 12 men can complete their work in 9 days. After they have worked for 6 days, 6 more men join them. How many days will they take to complete the remaining work? So the case is here. This is the total work. 12 men work for 9 days, right? So what is the total work? men into days. So 12 into 9, 108 units is the work. So 12 men, 9 days. Men into days is work, right? So 12 9 is the 108 units work is there. But after they have worked for 6 days, so initially 12 people are working, right? So this 12 men, they work for 6 days. So 12 men work for 6 days, 12 6 are 72 units work is done. Later on, what happened, guys? Later on, 6 more men joined. Initially, 12 men are there. If 6 more men join, the secondary case, the number of men are 18. Now, how many days will they take to complete the remaining work? We have the total work 108. Out of 108, in the first 6 days, they can complete 72 units. The balance work is 36 units. This work is done by 18 men in D days. So what is D? 36 by 18? It takes simply 2 days. Somebody may think this question can be done without even using this process, because initially they work for 9 days, right? Total that work is done for 9 days. Out of this, 6 days already work. If additional men join, the work should complete in less than 9 days. What is the number that should be added to 6 to get less than 9 as sum? Of course, only 2. But why I discussed this process is, sometimes options are, every option is less than 2. That time, you should know the process of solving. So simply convert into men units, it becomes so simple. Next, move on to the next model. A certain number of answer sheets can be checked in 12 days, working 5 hours each day by 9 examiners. Let us convert in terms of work units. So 12 days, right? 5 hours and 9 examiners. For how many hours a day should 4 examiners work to check twice the number of answer sheets in 30 days? 30 days, we don't know how many hours, right? Let us take hours. But friends, initially they were correcting these many papers, but in the new condition, they were checking twice the number of answer sheets. So now the present work is 2 times of previous work, right? This is new work. New work is 2 times of old work, right? In the first case, what is the work? I mean, in the old case, what is the first work? 12 days, 5 hours, 9 examiners. So this is the old work. That is 12 days, 5 hours, 9. But new work is what, guys? New work is 4 into 30 into H. But new work is 2 times of the previous work, right? Because in the new case, they were correcting. They are checking the papers twice the number of previous answer sheets. So we need to multiply with the 2 for the previous case. You can do mistake, I think, in this case only. Sometimes they may say 3 times work, 4 times work also. So here, 5 goes 6 times, 2 goes 3 times in 6, 3 goes 3 times, and 4 goes 3 times in 12, 3 into 3, 9, H, the hours is 9 hours. So this is simply option D. So we are able to finish the work. We are able to answer this question in hardly 2 steps if you correctly understand this twice the concept, right? Now, let's slowly increase the difficulty level. Now, let's see another question. This is a very good question, I can say. 100 men were to complete a piece of work in 20 days. After they work for 10 days, 60 more men were employed to complete the work on time. If additional men were not employed, then how many days behind the schedule the work would be finished? Friends, what is the initial work? Initially, they thought to finish the work in 20 days, right? They thought to finish the work in 20 days only. For that purpose, what they did, they hired 100 men. 100 men they hired. But after 10 days, they work for 10 days, guys. Initially, they work for 10 days. After this, they additionally hired 60 more men. So in the second case, what is the number of men? 160. So because of this additional hiring, they were able to finish the work on time. Friends, what is the total days to be finished? They have to finish in 20 days, right? Out of 20 days, in the first case, 10 days work is done, which means The remaining 160 people also work for 10 days. Now let us try to find out what is the total work done in both cases. Here 100 men for 10 days, right? So 100 into 10, 1000 units work is done here. How? We know work is men into days, 100 men, 10 days, 100 into 10. Here 160 men for 10 days. So 160 into 10, 1600. In the first 10 days, 1000 units. In the later 10 days, 1600 units. What is the total work? The total work they did is 2600 units. So this is the total work done. But if additional men were not there, which means what? All 2600 units, if only 100 men were there, if additional men were not there, whatever the people are there at the beginning, those 100 people only work. Let us see how many days they will take. Now 2600 units work is done by 100 men in how many days? Work is M into T. So 2 zeros gets cancelled. Now we got the days as 26 days, which means what, guys? Without any extra help, without any additional hiring, they take 20 days. So how many days extra they have taken? They have taken 6 days extra, right? Initially, they planned to finish the work in 20 days. In case if additional people were not joined, they would have taken 26 days. How many days behind the schedule they have finished? 6 days. So option D is correct. This is very, very, very important model. Let us go for another such numerical. In company X, a certain number of engineers can develop a design in 40 days. If there were 5 more engineers, it could be finished in 10 days less. How many engineers were there in the beginning of the work? In the beginning, we don't know how many people were there. Let us take N people are there, and they can design the work in how many days, guys? 40 days. So this is the work one. But if the same design, they are done with another conditions. If 5 more engineers are there, so now the number of engineers are N plus 5. So guys, as per understanding, work equal to M into days, right? Men into days, right? So initially N engineers are there. They work for 40 days. This is design one, work one. But the same design, so work is same, right? The same design, if 5 more engineers are there, N plus 5, it have been taken 10 days less. So initially the days are 40 days. Now 10 days less means they can do in 30 days. Now work is what? Work is men into days, number of people into days. As work is same, right? They were designing the same product, same work. Equate the work. So 0, 0 gets cancelled. So 4n equal to 3n plus 15. So n is 15, which means initially 15 engineers are working on the product. So option 5. Very simple question, right? Let's move on to the next question. Yeah, this is a very good question. Last question for this video, I hope. So Ram decided to plow a farmland in 50 days. He employed 50 men in the beginning and 50 more after 35 days and completed the construction in the stipulated time. If he had not employed the additional men, how many days behind the schedule would have been finished? So let us understand the question. Initially, they planned to finish the work in 50 days, right? They planned to finish the work in 50 days. Then what they did, he employed 50 men in the beginning. So in the beginning, they employed 50 men and 50 men and 50 more after 35 days. So guys, initially the number of men are 50 days. They work for 35 days. But after that, they additionally acquired 50 more. Means what? In the later case, the number of persons are 100 persons and completed the construction in stipulated time. So they plan to finish the work in 50 days, right? So here 35 days work is done. The balance days are 15 days. And here 100 men work for 15 days. So that they finish 35 plus 50 or 15 in 50 days time. Now let us consider what is the total work. So the total work is what? 50 into 35 is the work work. 35 5 is 175, right? Into 10, 1750. Here the 100 men for 15 days. So 100 into 15 is the work, which is 1500. Now friends, in the first 35 days, 1750 units. in the next 15 days, 1500 units. So totally 3250 units they work. So this is the total work, right? If additional men were not there, let us see how many days it will take. So this 3250 units is done with initial number of people. How many people are there at the beginning? 50 people are there in the beginning. We don't know they work for how many days with this condition. So 0, 0 gets cancelled. 5 6 are 30, 5 5 are 25. So now, if additional men were not there, they have taken 65 days to finish the work, which means what? They take 15 extra days to finish the work if additional people are not there. So option 5 makes sense. Option 5 makes sense. So simply we are multiplying men with days. I hope we have one more question of this type. So let us do to get more practice. Now, last question of this video. A builder decided to build a farmhouse in 45 days. He employed 150 men in the beginning and 120 more after 30 days and completed the construction in a stipulated time. If he had not employed these additional men, how many days behind the schedule would have been finished? Now we request you to pause the video and try on your own. If not, you can watch it. So now friends, they plan to finish this work in 45 days, right? They plan initially to finish in 45 days. And for that matter, they employed 150 men in the beginning. So men 1 are 150. And after 30 days, 120 more they employed. So that means what? Initially, the days are 30 days. They work for 30 days. Later on, they acquired 120 more. Means now the number of people are how many? Already 150 people are there. If 120 joined, now the men will become 270. How? Already 150, now 120 joined together 270. And with this extra help, with this extra hiring, they finish the work in the stipulated time. So they plan to finish in 45 days, right? Initially 30 days work is done. The balance days are 15 days. Now let us consider what is the total work done in these days. So 150 men for 30 days, 15 3s are 45, 4,500. Now 270 men for 15 days, 15 into 0, 0, 15 7s are not 5, 15 to the 30 plus 10, 40, 4050. So what is the total work? Sum of these two. How much is that, guys? 8550 work is done. So now this is the total work done. Now this 8550 units, let us see how many days they will take if no extra men were not joined. So initially how many men are working? 150 men are working. Yes or no? Now this 8550 work is done by 150 men in how many days? We don't know. Now 0 0 gets cancelled. 15 5s are 75. 10 remainder. 15 7s are 105. They are taken 57 days without any extra men help. So they plan to finish in 45 days. Without extra men, they would have taken 57 days. So how many days extra they have taken? So 12 days behind the schedule have been finished. So option 2 makes sense. So in this way, you can solve more and more questions on chain rule. So we thought to do efficiency based chain rule questions as well, but I thought it is better to discuss another set of questions, another set of 10-12 questions to understand efficiency concept in detail. So in the next video, I'll show you efficiencies with chain rule as well. First, I'll try to solve 6-7 questions on efficiency model along with the concept. Then I will try to do few more chain rule with efficiency model. So thank you so much for watching this video. And if you want to get more such updates, you can subscribe to our channel, learn QA and LR, and wish you all the best for your competitive exams. So keep learning, keep inspiring, friends.